For example 1, I want to look at some applications of linear equations. So here we have something called a mixture problem. What this is if I have a solution, so I'm saying I have 2 liters of something that is 10% acid, that's like its own thing, and I also have 3 liters of something that is 50% acid. What would happen if I poured these things in together? The percent of acid in the final mixture should be something between 10% and 50%, but what is it exactly? So to answer this question, I'm just going to jot a few things down. I'm going to start with setting up an equation. On one side, I'm going to put what I'm mixing, so maybe I'll make that the left side. So, what I mix when I pour these two things together. And on the other side, what I end up with. So that'll kind of help motivate setting up a particular equation. So maybe just to note one other thing, what is the concentration of acid in the final mixture? Anytime you set up an equation, we're going to need a variable, so I think we should define one. I'm going to let x equal that final concentration. And with all of this, we should be able to set up an equation and solve for x. So to start with, what I mix, I'm going to start with this 2 liters of a 10% acid solution. I'm going to take 10% and I'm going to write it as a decimal. So that is 0.1. And I'm going to multiply that by 2. That is the percent times the amount. That tells me how much acid is in the first solution. If I do that same thing for the second solution, it's 50% of something, and we have 3 liters. That is the amount of acid in the other solution. If we're saying we're mixing these two things together, the operation that we're going to use is addition. So the left side of our equation will always look like this. It's always going to be a percent times an amount, a percent times an amount. Since I'm adding two things together, I just put a plus sign between them. So I mixed those two solutions. Now on the other side of my equation, it's what I end up with. And there's just going to be one single solution. That means I'll only have one piece, not two separate things. Now, it's always going to be a percent times an amount, and x is the percent that I'm ending up with. So I'm going to write what I end up with as x times some amount. It's going to be some percent, I just don't know what it is, times an amount. But I do know the final amount. If I start with 2 liters and I pour in 3 liters, that's a total of 5 liters at the very end. And that's essentially it for this problem in terms of setting it up. I mean, once I have the equation, setting what I mix to what I end up with, I just have to solve this thing for x. So to do that, I'm going to multiply things together, combine some like terms, and try to get x by itself on one side. So I'll start doing that. On the left, we have 0.1 times 2, that's 0.2. Then we have 0.5 times 3, which is 1.5. And this is equal to, okay, 2 and 3, obviously that's just 5, and you're multiplying it by x. We would write the 5 first, so I'll just say 5 times x. Moving forward, on the left, I can add 0.2 and 1.5, that's 1.7, and that still is equal to 5x. To get x by itself, I can divide both sides by 5. So on the right, that's perfect. It gives me x, the thing I'm solving for. On the left, 1.7 divided by 5 is 0.34. You can check that on a calculator. And if I convert that to a percent, by moving the decimal 2 places, that is 34%. And I was expecting something to be between 10 and 50%. I mean, it should balance somewhere in the middle, and 34% definitely works for that. So what all this means is, if you were to mix something that is 10% and 50%, 3 liters of one, 2 liters of the other together, we would end up with something that is 34% acid. And for example 2, same idea as in example 1. This is just going to be a slight variation on that. So I'll read through it. Suppose you have 2 liters of a 10% acid mixture, but this time what you want to end up with is something that is 35% acid. How much of a 70% acid solution must you add to increase the concentration to 35%? So just to see what's going on here, we have this one solution, but it's only 10%, and you want to increase this to 35%. Well, if you were to pour in something that is 70%, it should definitely raise this. But the question is, how much do you have to add in to accomplish this? This is different than example 1 because now we're not solving for a concentration. We're actually solving for some amount of liters that accomplishes this goal. So I'm going to start this by defining my variable. X is going to be the number of liters of the 70% acid solution. So we have as much of this as we need. I just want to pour in the exact amount that would take me from 10% up to 35%. But the good news is we can use the same concept in the last example where on one side of my equation it's going to be what I mix, and on the other side it's going to be what I end up with. It'll look really identical. I think the variable is just going to be in a different location. So to start this one out, I'm still going to do 0.1 times 2. That's the amount of acid that's in the first mixture. And I'm going to add to that. Now I'm pouring in something that is 70% acid. So I know it's going to be 0.70. But now I don't know how much I'm pouring in because I'm calling that X. So in your equation, you can just place X. So this is the difference. The X is now on the left side of the equation, where it was not in the previous example. Okay, now on the right side, I'm going to place what I want to end up with. Now I want something that is 35% acid, and in parentheses, I'm going to write how much of that solution I'm going to have. Well, we have 2 liters, so I know it's going to be at least that, but since we're mixing in some unknown number of liters, I'm going to put plus X. So this is different too. I mean, the X is appearing on both the left and the right side. So that is, X is how much I'm pouring in. The best way to write that is 2 plus X as my final amount over here. So this side was what I mixed together. This side is what I want to end up with. I can now ignore all of that meaning and just try to solve this linear equation. All right, so going from left to right, I have 0.1 times 2, which is 0.2. I'll just write this as 0.7x. I can't do anything else on the left side. Now on the right side, I'm going to distribute in the 0.35. So 0.35 times 2 is 0.7. And when I multiply it to x, I get plus 0.35x. So let's see. I'm going to set this up so the coefficient in front of the x is positive. So I think my next step will be to subtract 0.35x from both sides. And when I do that, I get 0.2 plus 3.5x is equal to 0.7. I'll now subtract 0.2. And I have 0.35x is equal to 0.5. The last step will be to divide both sides by 0.35. And I do get x all by itself, and I'm going to get this value off of a calculator just to see what this is equal to. Okay, I get x is equal to, it's a decimal that goes on forever, so I'm going to round it maybe to 2 decimal places just to get an idea of what this is approximately equal to. So that's 1 point. If I go 2 places, I get 4.3. So that's liters. What this answer means is, if I started with 2 liters of something that's 10% acid, and I wanted to go up to 35%, you would have to pour in approximately 1.43 liters of this other solution to accomplish that goal. So obviously the more precise you want it to be, the more decimals you would add to the end of this answer, but I think this is good enough for example 2, and that's it.